Hi everybody, this is Shujat Mubarak and this is the third video of our one-way multivariate analysis of variance test series. In fact, in the previous two videos we discussed about the basic assumptions of performing one-way multivariate analysis of variance. So in order to see the various assumptions, you can watch our other two videos in which I have very briefly explained about the assumptions and how those assumptions can be performed on the SPSS, except for the last assumption, that is the homogeneity of variance. Homogeneity of variance is in fact the results of this particular assumptions come with the one-way MANOVA results once we perform on the SPSS. So in this particular video I'm going to perform the main one-way MANOVA test on SPSS, and then we'll be interpreting the results of that particular test. Let me again to remind you that our main research question or the main our aim for performing one-way MANOVA in this particular example was to check whether the three variables which are total negative effect, total positive effect and total perceived stress, whether males and female differ by the total negative effect they receive, total positive effect they receive and total perceived stress they receive. So is there any difference in male and female on these three variables? Combinedly these three variables are called the well-being. So well-being has been represented by these three separate variables. So we are applying one-way MANOVA. Let's go toward this SPSS, how to perform this one-way MANOVA. Simply we go to analyze. After going to analyze, we go to the general linear model and then multivariate. So here in the multivariate, since I've already performed one-way multivariate analysis of variance, so that's why here the dependent variables are appearing. Normally it would be a blank box and you have to simply drag your dependent variables. Here in our case we have the three dependent variables: total positive effect, total negative effect, total perceived stress. So I've dragged those variables here. In the fixed factor, our independent variable, that is gender or sex, it would be coming here. Right, afterward we simply click on model in order to check whether this full factorial button is clicked or not. We can just see it's clicked already. So we simply click on continue, then we go on the options button, and what we do is normally once we click on the option button, so it's like this, and obviously these won't be ticked. So what we have to do, we need the mean of the data by gender, right? We want to check, maybe we want to compare the mean of the male and female differently. That how, for example, for the total perceived stress, what is the mean value of male and what is the mean value of female, for likewise for the other two variables. So for that we have dragged here displays mean for this variable. Then we need the descriptive stats, we need estimates of effect size and homogeneity test, right? And then we go on continue, we click on OK. So these results would be appearing. You can see the results of descriptive stats, equality of variances, multivariate test results, and then there's a Levene's test of equality of variance, then there's a test of between subjects, and finally is the estimated marginal mean. So these results have been already transferred to the slides. In fact, the way it appears or the way we write, I have already told you that the results are discussed in the format of DDM, that is descriptive stats first is discussed, then the diagnostic test, and then the main findings. So first table is showing the descriptive stats of the data. It's showing that total of 432 participants were there, or respondents were there, among which 184 were males and 248 were females, right? Now let's come toward the diagnostic test. As we have already performed 5 other diagnostic tests, this is the you can just see here the 5 other tests which we have performed. So this is the 6th test, homogeneity of variances, which is being tested in 2 steps. First we check the box test of equality of covariance matrices. Basically what this test is doing, it is checking, it's taking overall data and then it's checking that whether our data violates the assumption of homogeneity or not, right? So in order to violate the assumption of homogeneity, the value of this SIG, significance value, should be less than 0.05. So if the value is less than 0.05, it means the data is violating the assumption of equality of covariance in matrices. If the value is greater than 0.05, it means that data is not violating the assumption that data is fit for applying one-way MANOVA from this perspective. So we can see that our value is 0.331, which is greater than 0.05. So we can say that our data is qualifying the box test assumption, and then we can move forward. So this test is taking data as a holistic. But this is test number 2, which is the Levene's test. It takes the individual variables. It checks the individual variables equality of variance, right? Total positive effect, total negative effect, and total perceived stress. These are our 3 dependent variables. So you can see here the significant values: 0.303, 0.264, and 0.151. So it's showing that individually these variables are qualifying for one-way MANOVA by having the equality of error variance or not. So if the values are greater than 0.05, we can say that our data is qualifying for one-way MANOVA test, as our data does not violate the assumption of equality of error variance, right? So in our case, all the data series are greater than 0.05, and we can say that our data is fit for applying one-way MANOVA, fit for having the one-way MANOVA. So now let's go toward the main findings. After first we explained the descriptive stat, then diagnostic test. Now we come toward the main findings. In fact, the main findings of the data appears in 3 steps. The first step is multivariate test. It simply tells us that whether there is a difference among the dependent variable by categorical variable by the dependent variable which we have or not. Means if this value is significant, it's showing that one of the variable, or maybe one or more than one variable, differ from each other once divided into the groups of male and female, right? So the value we check for in order since you can find a lot of values in this against this value of our independent variable, gender, sex. So we normally in social science and management sciences, the Wilks lambda value is checked, and here you can say the Wilks lambda value is 0.014, which is obviously less than 0.05. It's showing that there is a statistically difference between males and females in at least one variable, right? Because this is showing that once data taken together, whether there is difference in one variable or not. Now where that difference exists, we have to move forward to check that. That test is test between subjects effect. Again, we have to go here in the gender or sex, and then we have to just check this significant value. Normally you remember in the previous test what was our threshold value? That was 0.05. It's less than 0.05, it's significant. If it's greater than 0.05, it's not significant. But here we are not keeping that threshold value of 0.05. Why? Because there may be the chances of type 2 error. So in order to avoid the type 2 error, what we do, that we set our alpha level in a stringent way. It means that in order to avoid a situation where we have rejected hypothesis which should not be rejected, so what we do, we do not keep the 0.05 as our threshold value. What we do, we divide 0.05 by the number of dependent variables we have, and the resulting value is our threshold value. So in our case it is 0.017. So what we do is, for example, this the process of dividing alpha, process of dividing the significance value of 0.05 with dependent variable, it's called Bonferroni adjusted value, right? In order to set the stringent level of alpha. So now this 0.017 would act as our base value in order to test the hypothesis. If the value is, if the significance value is greater than 0.017, it means that we cannot that there is no difference. We cannot reject the null hypothesis. If the value is less than this 0.017, so obviously then we can reject the null hypothesis. So you can just see here that 0.927 is obviously greater than 0.017, 0.064 is also greater than 0.017, but this 0.004 is less than 0.017. So it means that in terms of total perceived stress, males and female differ from each other, right? But in terms of total positive effect and total negative effect, there is no difference. Further, in order to see the magnitude of the difference, we can check the partial eta square value, which is 0.019 in our case. Obviously it's showing that the difference is not very large or moderate, it's a very small difference. So it shows that although there is a difference in term of total perceived stress by males and female, but difference is not very large. It's a small difference. This difference further can be analyzed by comparing the mean values of the males and females. You can just see that the total perceived stress male mean is 25.788 and females mean difference is 27.419. So not a very large difference. This is a small difference, but obviously statistically significant difference between males and females. How we can present these results? This is how we present the results. In normally there may be there are a lot of ways to present the result. This is one of the way to present the results. First, you explain your research question, that for what purpose you have applied. A one way between group multivariate analysis of variance was performed to investigate sex difference in psychological well-being. Obviously that psychological well-being is measured by the three dependent variables. Those are positive effect, negative effect, and perceived stress. Independent variable was gender. Now then you come toward your diagnostic test. That preliminary assumptions testing was conducted to check for normality, linearity, univariate and multivariate outliers, homogeneity of variances, covariance matrices, and multicollinearity with no serious violation. So all they have very compressed in one line, that all the process of diagnostic test. Then now come toward the main findings. There was a statistically significant difference between males and females on the combined dependent F variables. Mean the first multivariate statistics finding, which is showing that there is a difference. But when the results for the dependent variables were considered separately, the only difference to reach statistical significance using a Bonferroni adjusted alpha y level of 0.017, this you remember, that was perceived stress with partial eta square value of 0.02 almost, right? So an inspection of the mean scores indicated that females reported slightly higher levels of perceived stress than males. So this is the way you can interpret the results of one-way multivariate analysis of variance. If you have any question related to this one-way multivariate analysis of variance, you can simply write in the comment box of this YouTube video. So I'll try to respond you your queries or your questions by replying to your comments. Thank you very much.